Today I'm going to be reviewing what's inside this bag here. Do you know what it is yet? Let's open it up. Now the video title probably gives it away anyway. So it's a smart meter user manual here. Oh, it's a bit crumpled up. Yeah, I fixed it. I'm not quite sure why it's come in two bags. It seems a bit strange. So we've got some extra probe packs here. Little screw-in probe type setup. This is the actual operating manual. For some reason we've got two of them. So one is a Chinese manual and one is the English manual. And we've got another probe pack. More like standard probes, Donner jacks, that sort of stuff. Thermocouple. It's the Aneng 682 smart multimeter. Has a charging cable as well because this has got an internal battery which it uses. Now this is supplied to me at no cost by Banggoods. So thanks so much Banggoods for providing this to me. What's this? Interesting. Let's open this thing up. It's got like a residue on the screen or something. I don't know. You can see this. Can you see the pattern there? So here's the USB charging port on the back. USB-C. 3 ports under there for the actual connections. Common input and input. Okay. So you've got milliamps and amps, the common terminal, and volts, ohms, something else and something else which I can't see. Hertz, temperature, diode test. This is an LCD screen. So let's have a look at the probes that are supplied. Oh, these actually feel like silicon leads. These are silicon leads, but they also feel extremely thin. I think the wires in these are not very meaty, actually, but they're very flexible silicon leads. That's actually quite nice leads. They're very lightweight, but I think the actual wire inside is going to be quite thin. I don't think there's actually going to be much wire in there, so I wouldn't be putting too much current through them. But all other measurements are probably fine. You've got a thermocouple probe. I'm not going to bother getting out of the bag. And I also got this other probe kit which came with it, because it came with a big assortment. So these are plasticized PVC. So we've got these screw-in tips and things like that in here. Spade terminals. These sorts of things are handy sometimes. These kinds of kits. I mean, these probes aren't particularly wonderful probes. So in that regard, these are, you know, budget things. They work okay, but you know, sometimes you want something a bit better than these. I mean, that barely even touches, I suppose. I mean, it's kind of going to work. That might have some thread damage on there. Let's try the other one. That one screws in fine. So there's an issue with the threads in this side. It's probably a bit of swarf in there or something. They manufactured them. This sort of thing can be handy. Sometimes you do want a little cheap pair of leads like this, which you can adapt to suit a certain situation. So, I mean, they're okay. It's not something I normally turn to, but sometimes you do want something like this just to get the job done, you know. So let's have a quick flick at the flick through the manual here. You can read that in your own time. The only page I think I'll hang on is the specs. Okay, and here's the specs. So 6,000 count, 0.5% to 0.8% on DC voltage, 0.8 and 1% on AC voltage, AC and DC current 1% or 2.5% depending on range. Resistance is 0.8% and 1.2 or 2.5% depending on range, and this actually apparently goes up to 60 meg. That's quite surprising. Frequency response is up to 1 kHz, 10 amps max, continuous current of 5 amps, maximum AC voltage is 750 volt, 10 megohm impedance as you expect, is, you know, commonly used. Capacitance mode is up to 100 millifarad. What's your diode test, which is 3.2 volts apparently, which is alright if it does that. Beeper is a resolution of 0.1 ohms. Less than 50 ohms it will beep, it seems. Temperature, obviously two ranges in centigrade and Fahrenheit. Frequency is up to 1 megahertz apparently. 2 volts sensitivity with 0.8% accuracy. More instructions there, read those to yourself. Right, So there'll be links down below for this thing, and make sure you go and check that out because there will be probably be discount codes as well. I think Banggoods doing a special, so I think you get some extra discounts as well on top of the standard price. So let's power this thing back up again. Just have to hold it, do I? Yep, have to hold it. Now one thing I don't like is the way the leads come in the bottom, because if you want to prop it up you can't. You can't do it like side on like this, and even that doesn't stand. So yeah, it has to be flat on the bench. And I'm not liking this display then, it's really dim. Can you actually see that there? This bit's looking reasonable. I mean, I've got quite bright lighting here. You can see the angle, so it's basically 90 degrees to the camera. Alright, so it's tipping upwards slightly, so downwards slightly. You can see downwards is looking much better. Right, that downwards angle was what it's designed for. So sitting on a bench like this is actually designed for that angle anyway. These probes, like I said, the silicon leads. And actually got these nice staggered sizing, so it actually comes down to a nice fine size here. This can actually really handy, this kind of dimension, because you can push these into connectors and all sorts of things and get them into smaller areas and, you know, do finer probing. And these look like they're gold plated. So just in auto mode. So continuity is obviously dropping into that, or resistance or something. Let's change modes, so let's do select. So that's diode mode. Does it beep? No, diode mode doesn't beep. Next mode, this is continuity mode. That's very fast actually. It's latching. I keep missing it, that's why it's not going off. That's actually very fast. That's good. In manual mode it's really fast. EF, electric field. Can I get to trigger? I'm sticking that into a 240 volt power point. Give you some idea. There we go. So that's just one probe plugged in to the power point. Let's try the other probe. Yep. So either probe will detect electric field. That's 240 volts though. Live contact, well, let's look for a voltage somewhere. That's obviously not non-contact. Let's do this one again. Yeah, so that's doing the same as electric field. And what's this one here? Oh, display's looking a bit weak there. When I went to centigrade, Fahrenheit, Hertz. We'll check that out later on a calibrator. And back to standard mode again, because it's got a non-contact thing there. Was that in the first mode I did? Electric field. Okay, electric field is doing non-contact. Right, so that's non-contact. And this one here is doing the wires. This is being a bit slow to fade in and out. I wonder if this battery voltage is a bit low, because I haven't charged it yet. I might try charging it up, I'll come back. So I have this on charge right now, and with it turned off it's drawing about half an amp, and with it turned on it's drawing about 600 milliamps. Looks like it's using about 100 milliamps at least to run. You know, with it on charge it didn't actually seem to improve the issue with the segments being a bit slow to react. Yeah, interesting. Well, I'm going to leave this thing on charge for the time being whilst I'm working on it, because I need to do more testing on it yet. Power it back up. So I'm going to do capacitance testing. I'm also going to put this on my Datron 4700 calibrator as well, so I can check the voltage accuracy, frequency accuracy, you know, AC, DC, volts, resistance, and current as well. I can check all those with the Datron calibrator. We'll put this through its paces on the calibrator and actually see how accurate it actually is, so make sure you stick around for that. First thing we'll do is we'll check the capacitance. We've got a plug-in capacitance thing here. It's just the same spacing. It is a 19mm spacing, so this is a 200 picofarad cap. Does it detect it? It's not quite sure what it is. Just trying to figure it out. So let's go to capacitance mode, which is pushing that. And it's detecting 175 or so. 76, yeah, it's slightly low, but not too bad. Okay, let's go to this next capacitor over here, which uses this flying lead instead. Chuck that in there. This is a 1 nanofarad cap. And there we go, that's what we're getting on that. So it's actually not too bad. It's about, you know, 20 out or so. I've tested this thing at 1.006 nanofarad at 10 kilohertz, 1.002 at 100 hertz. So this is actually sitting slightly high. Okay, let's try the next one. The next one. So the next one is a 20 nanofarad, and that is reading again about 20 high or so, 20-30 high. And the next one is a 1 microfarad, which is reading low. I know this one's actually really accurate, and this is sitting low. Accuracy and capacitance, yeah, it's ballpark. Is it accurate-ish? Not really, but you know. So the next test I'm going to do is using Ian Johnston's DMM continuity tester. Alright, so this is something he sent to me. He makes these available. These are open source, so you can actually download them and make them yourself, get the boards made and stuff like that. Just turn this on and see what it thinks of it. So basically this thing puts out pulses. So it's got a mark space ratio, 5 millisecond pulse with a gap of 245 milliseconds. So the total period is a quarter of a second. So what this should actually do is trigger this to be sensing a short circuit, like like you do on a continuity testing. So if I gradually increase this mark ratio, eventually this will start to sense it. You can see it's already reacting on the screen, but there's no beeper coming out. So the screen's showing it, it's doing something, but I don't think it's in auto mode. When I go to manual mode, it will change it completely. So it beeped once then, it's still trying to figure stuff out, can't really do it. No. Now the best multimeter I've got will actually do a beep with this set as the lowest setting. That's the best meter I've got that can actually do that. There we go, starting to react a bit more now. So it's got the auto mode. Oh, almost. 250 is as high as I can go on this thing, and it's actually not doing it. So let's change modes manually. Okay, let's wind this down. That little pattern where it skips one, that's actually part of the firmware of this thing. It's a little glitch in the firmware of this, which Ian has actually fixed. I just haven't updated the firmware on this thing to actually replace it. But there we go. So below 1 millisecond is no. .9 milliseconds looks pretty reliable, maybe slightly more than that. No, it's missing a couple actually. Yeah, I think it's missing more than one. Yeah, it's catching most of them at that speed. There you go, 7 milliseconds is really reliable. Which isn't actually that bad. That's actually doing okay, really. I've seen far worse, but obviously only in manual mode. Auto mode was pretty much useless. So as I've got this thing on charge, you can actually see it lights up the end there. You can probably just see it. Lights up red, but it's on charge. But that's also where the torch is. So if you actually hold down this button here, there's a torch with an LED in there. It isn't wonderful, it does a little bit. I suppose if you're in pitch black it'd probably be handy, but generally I think it's not going to be particularly useful. More of a gimmick than anything else. I think we're just about ready to go over to the calibrator. I was going to give this thing a bit more of a charge up, get it fully charged, and then I'll go over there because it could take a while to do those tests. Also, you have to excuse this wiring mess in the back here. I'm doing a load test on this battery here. This is a Baofeng BF888S battery, which I picked off AliExpress. Claims to be 3,300 milliamp hours. It is not. I'm doing a discharge test on this right now using my Signalant load of 150 milliamp hours, and I'm going to see how long it takes. So it should take 20 hours. I think it's going to take about 7. So over here at my Datron calibrator now, I've got it set to auto range. Let's turn the voltage on. This is set to DC volts right now. 0 volts output, and it's currently seeing resistance.
chaotic.
A few moments later.
Let's do 100 microvolts. Still seeing resistance. 1 millivolt. Still doing resistance. 10 millivolts. Still doing resistance. 100 millivolts. Still doing resistance. 1 volt. Finally notices voltage. And it's only 1 count out. So what I might do, if I push select on that, does that lock it in? No. So let's go around to manually select voltage. Huh. Really? Didn't notice that before. I can't actually select voltage directly. I can only do diode voltage. That's curious. But if I do voltage again, the 10 volts, what happens? It goes auto range into voltage mode. So it looks like the voltage mode is only auto ranging. There's no obvious way here of going to manual voltages. So 10 volts is 2 counts out. 100 volts, 1 count out. I don't know what it said for the maximum voltage this thing can take. I suppose we could find out. Let's drop this down a bit and go up to 1000 range. So shoving in 200 volts, give it a chance to detect it. It got there, took a while. 300. So it's only a couple of counts out the whole time. It's actually not bad. 1000 volts. And it hasn't gone bang yet. Does that make it a winner? Maybe. Back down 100 volts. Back down to 10 volts. So let's find out what this threshold actually is for it to detect voltage properly. Something else. So let's go back to that. So 10 volts. It's detecting that. Let's bring it down and see when it switches over. What's its minimum? It's got this little bar graph here, which isn't actually that fast. It's no faster than the display itself. It's more of a gimmick, I think. It'll tell you where you are in the range, I suppose. So down at 1 volt, it's still on 1 volt. Let's drop it down this way. So going downwards. There we go. Threshold's about 400 millivolts, I think. And now it thinks it's resistance. And at 800 it goes over to the voltage range. It's just a bit slower. Yep, 400 millivolts. It goes to auto ranging. And right now it's stuck. It doesn't know what to do. Exactly 400 millivolts. It's locked up. Yeah, so at 600 it detects as a voltage. So if you're doing anything below 1 volt, this probably isn't the best thing for you. Anyway, let's try AC next. So I'm currently doing 1 millivolt at 1 kilohertz AC. Turn it on. No. 10 millivolts? No. 100? No. Beeping, that's an interesting thing. It's going into continuity mode. 1 volt AC, there we go, now we're seeing it, and also seeing frequency. Both have a 1 count. Not too bad, actually. So let's change frequencies. So let's do 100 hertz, and that's looking 1 count out. That's alright, I suppose. Let's go 50 hertz. Yeah, 1 count out. 20 hertz. This is usually where things start to have trouble, is really low frequencies. But it's actually still doing okay. 10 hertz, which is as low as I can go on this thing. And you can see the frequency, and it's actually doing surprisingly well. You don't normally get that kind of response. 1.5 kilohertz, and it's still working. Accuracy is starting to drop off. It was rated to 1 kilohertz, so we're above that. Yep, see, accuracy is dropping off because you're above 1 kilohertz. But that's okay, it's still usable. Let's go 10 kilohertz. Well, it's going to go to 20. What happens? It's going a bit crazy. increase the voltage, because it was rated at 2 volts threshold for frequency, and yeah, it just doesn't really know what to do with that, does it? Yeah, 100 kilohertz. I mean, it did mention frequency at 1 megahertz, but it can't figure it out. Back down 2 kilohertz again, and yep, there we go. Yeah, I don't think it can do 1 megahertz somehow. It just doesn't know what to do with it. So let's go up the voltages here. That's 1 count out on AC there, 1 kilohertz. I'll do the rest of the test at 1 kilohertz. 100 volts, it's bang on. Frequency is out by 1 count. That's alright. Let's drop this down a bit. So 400 volts, 1 count out. That's okay. This is spec to 750 volts max. Let's see what happens when we go to 800. Okay. Beeps, that's fine. 1000 volts. Doesn't like that, unsurprisingly. Okay. And it still survives. Good start. It's not blown up yet. Let's check resistance next. Right, let's check resistance. I've got this set up for 2-wire mode, because this is obviously only a 2-wire device. Got the lowest range, which is 10.42 ohms. Let's turn it on. That's actually pretty quick, and it is actually accurate. That's alright. 100 ohms. No more beeping because it's no longer continuity mode. And it's 100.4. I'm getting 100.4-ish. Sliding around slightly there. 1K. Yeah, that's okay. 10K is 1 count out. Reasonably good, that's well within spec. 100K, 1 count out. Ignore this temperature reading you see on the phone here, 27. It is not 27 degrees in here, it's only 24. 1 mega ohm, 2 counts out. 10 mega ohm is 2 counts out. 100 mega ohm it can't read because the maximum is 60, so that's actually looking okay. So I plugged the probes in here and it's detected I've already gone to DC amps, even though I'm not actually doing anything yet. It's detected it. Has that got probe sensing? Looks like it does. Just connect it in and switch to amps mode. Nice, that's a good feature. Well done. Well, let's see what happens. I've got this set up to the lowest range I can, DC amps, 200 microamps. 100 microamps does not show up. Let's do 1 milliamp, maybe it's below range. 1 milliamp, barely flicking up. See that? 1 milliamps just flicking up. So 10 milliamps, there we go, 1 count out. 100 milliamps, a few counts down. 1 amp is 1 count down. The most I can do on this is 1.9 amps. And it's actually looking reasonably good. Let's try AC amps out now. Turn that on. 1 milliamp AC, still showing DC amps. We'll see if it registers when I get high enough level. 10 milliamps, there we go, it's changed over now. Oh, it's flicking. It's detecting something. Yep, it's there, 2 counts down. Barely did it, but that's okay, it did actually detect it. 10 milliamps AC isn't a lot. 100 milliamps AC, 1 count down. 1 amp AC, 1 count down. Let's go to maximum. And 1.9 amps is only a couple of counts down. It's actually doing okay. Let's try changing frequency with 1 amp going in. Okay, so that's 1 count down, which is like our best result so far. Still 100 hertz. That's still good. And 5 kilohertz is way off. Alright. .2 kilohertz is way down. So yeah, 1 kilohertz is like the absolute maximum this thing can really do. reliably. 500 Hertz, yeah, it's about the same. So 1 kHz really is the top end if you want any accuracy out of it. But on this, it's actually not giving a frequency, which is interesting. Why does it have that display if it can't actually do it? So the next thing we should do is pull it apart. So it's like it will peel off the side here. Also, before I forget, click subscribe right now, quick, before you forget. Yeah. Let's peel this off and see if we can get into it and have a look inside. So it works basically the same way I thought it would as far as the accuracy specs go. I mean, it's pretty good accuracy wise, really. I mean, it's okay. It's certainly better than you used to get in the old days with the old analog meters and stuff like that, and the early digital meters. Accuracy's come a long way. It's actually doing quite well. There we go, there's that bumper off. There's some screws there. Yeah, the auto ranging thing is always a pain. Also, if you've not been here before, make sure you subscribe and click the like button if you like what I'm doing. I do lots of reviews, test equipment repairs, that sort of stuff, so if you haven't been here before, make sure you subscribe. I'll do some much more complicated stuff than this. Right, let's have a look. There's the lithium cell. So we've got a 2.8 amp hour battery, 2800 milliamp hours, 3.7 volt cell, which is reasonable. There is actually space in this casing to actually fit a larger pack in here. They could have actually done a bigger cell. I mean, it could have gone more this way and more that way. There was a space to do it. They could have actually put in something maybe 50% bigger than that and given you longer runtime, but I suppose that also costs more, so you know, there's a trade-off in cost, isn't there? These are made down to a price. This will be a display driver chip up here. Power coming in here, there's a voltage regulator there. Some MOSFETs or something down here. Maybe just transistors, can't tell. Bunch more down here, it's crystal, memory chip, processor IC, there's a relay, some MILF resistors, that's with an E, not an I. There's a PTC down there, and that appears to be pretty much the only input protection. The current shunt resistor right there, which is obviously used for sensor current loading, so it senses the voltage drop across that resistor to determine the current. And that seemed pretty accurate, it's working quite well. It's a 0.01 ohm resistor. But there's not much to see on here, there's a few buttons here, and those buttons on the side. Obviously this LED here, there's another LED underneath it, which is obviously done for the charging indicator. So one's a torch, one's a charging indicator. And also a single ceramic fuse, because it's only got one current jack anyway. And what's that rated to? That's a good question. Can't see. Let's pop it out and have a look. So interesting, this is a 7 amp fuse. So I would avoid going over 7 amps with this thing if you're doing any current measurements. I'm not going to pull the board out, there's nothing on the back of the board, it'll just be the display itself, there'll be nothing to see. Everything is on this side of the board. Do you want a closer look than this? You probably do. That's about as close as I can get. A few different angles. Do you reckon I can get the chip numbers off? ATP 16C something, is it? ATP 16C23. That's what that U4 is up there, that one right there. This one over here, the main chip. See if there's anything on there. Sometimes they laser mark them off. There is no markings on the chip, it's been lasered off, so you'll never know what that chip is. It's probably some generic chip anyway. But yeah, not much to see inside these things, as is usually the case. So a little trick for this thing, as you power it on, you've got to auto power off, which is a symbol which is normally on the screen up here. It means after 15 minutes the thing will turn itself off if it's not being used. It saves your battery, right? But if you don't want it to turn off because you're going to be using it for a period of time off and on or something like that, or you're monitoring something, you actually disable the APO. Apparently you hold the select button down as you power it up. So let's do that. Select button and power it up. And it's on, and auto power off symbol is now gone. So that's no longer going to shut off by itself. So what do I think about this thing? Well, the display is not great in bright light. If you're trying to use this outside, you probably wouldn't be able to see the display at all. I think it's going to be hard to see. The angle was good if you're sitting on a bench, you know, looking upwards at it. Construction looks okay, nothing to write home about. Accuracy seems pretty good. I mean, that USB-C port, that's in a cutout which is basically the same size as that port, and it lines up perfectly. So they've actually done a really good job of getting these alignments and fitments correct. That actually says a bit about the quality. If there's a massive gap around it, then you'd be going, okay, well maybe the quality is a bit hard to achieve. But the fact they've actually got designed that close that they can actually have the cutout basically touching the connector, that's actually quite a good thing to see, because that means their precision is really good, the accuracy is good. Cell size is okay, could be better, there was space for more. How long does it last? I don't know, we'll find out I suppose. But I think for newbies it's probably okay. I think one of the best things about this is actually these leads. I have to say, I actually quite like these leads. And I'm a bit fussy about leads, I have to say. But I quite like these. They're really flexible, quite lightweight. Nice probes, pretty sharp tips as well. Nice and fine points. They're not too long, so they're not going to get in the way. I actually might use these on some other meters actually. I might actually use them on those because these are actually quite nice probes. This isn't the sort of thing I'd normally use because, well, you know, I've got things like this and things like this. Right, so I've got some really expensive meters already which work very, very well. They should do because they're really expensive. This on the other hand is a fraction of the price. Accuracy is pretty good. As you know, that's alright. The auto mode thing, yeah, not great. But they never are. It's always a trade-off in the auto mode trying to figure out what actually the measurement input actually is. But if you're a newbie and you're getting into electronics and you're starting out, or you just want a cheap little meter and it's pretty accurate, then maybe this is worth a consideration. This isn't going to be for everyone. The display is novel. It is an LCD display. But like I said, in this bright light of that was making it harder to see. Because it is backlit. If I turn off some of my lights, to give you some idea, right? There's one light. There's another light. There's another light. And there's another light. This is normal room brightness, okay? And I also have an overhead light, which is like my main room light, that is still on. So I'll turn this on now. You can actually see it a lot better, right? Because now it says more normal lighting. So if you're actually working somewhere indoors, this is probably more likely what you're going to be seeing. So thanks a lot Banggoods for sending this to me at no cost. Check out my other reviews and stuff like that down there. Subscribe if you're not subscribed. Click the bell icon if you don't already have that clicked. And there's a Patreon support link over there if you want to help support me on Patreon, help me to buy things to repair, such as test gear, which is broken. One of my favourite pastimes is fixing broken test gear. Catch you later.